All right. Welcome to Five Live Free Code School. Okay. Dana, you saw the message. I got all the backlogged recordings up.
Yeah, it's good to see things.
Yep, absolutely. With all of my laxness on that, we're still only missing that one. And I do want to re-record that with you, where we sort of began the janky JavaScript project. I think we should have called it the janky JavaScript project from the beginning, but it's been helpful. All right, good. So we're continuing on with our designing an API. And where we left off, anybody have any questions before we just jump into it? Okay, cool. Where we left off was that I had asked you for homework to start building out the different routes for the 4 remaining endpoints. So to refresh the memory of the people who are watching, and also to refresh our memories, let me go ahead and share my screen. This is our API document, and we're looking at 5 different endpoints that are described in this little chart. We have built out an API that will at least arrive at the router for getting all products. And so I want you to build something that would handle creating a product, getting an individual product, editing an individual product, and deleting an individual product. How did you all do on that?
I attempted. I don't think that I did it right, but
Totally fine. Excellent. Alexandra?
I think I got it finished.
Okay. All right, let's take a look at what you have, and then we'll see if that answers any questions that Dana has as well. Is that cool, Dana? All right, let's go ahead and stop sharing. And go ahead and share your screen. Let's start by just looking at the one that already existed, which was just simply get all products.
Okay.
Of course, the rest of them are probably there. But if we look at your route.products.js, it was the top one on line 5, correct?
Yeah.
That's what we had. Okay, good. So the next one is getting an individual product. Okay. So you are saying that if we have the /ID appended to it, then we'll hit that reached router. Okay. If we have with the method of get, that's line 10. On line 15, if we have a method, an HTTP method of post, but it's at the root as defined on line 29, then that will be to create a product. That makes sense, posting. For updating or editing, if we have on line 20 the verb put, and we have that text of ID, then that'll reach updating a product. And finally, same sort of pattern on 25, but the method is delete. Now, is that similar to what you had, Dana?
not quite.
Okay.
Yeah, looks
Okay.
really different.
Okay, good. Go ahead and share your screen and we'll see what you have. And by the way, Alexandra, that's mostly correct. Passing in an ID, there's a specific syntax to use when you're using this Express framework. And I never memorize it because I don't memorize syntax. Okay, so you have, you've got a few different exports rather than one. And that's fine to do it that way. It just makes it harder to read, right? So you can, as you saw Alexandra do, you can put them all in one export. Does that part make sense, Dana?
Yes.
Okay, so if we look at the top, that was getting all, that's where we started. And the next one you have is create, and the pattern is a post, and then that's perfect, right? Now, obviously, we're gonna have to worry about how to get the body information from our request to use it to create one, but that's what we're gonna cover over tonight and probably Wednesday. So that looks fine on line 17 for create. Updating, you have a put, but we didn't address the ID at all, which is fine. Alexandra did, but we'll have to change the syntax on it. And then same thing for delete. You got the method right. What I'd like you to do is just strip out each of the individual router.post or router.put, like lines 20 through 23. strip that out and put it up where line 9 is. I hit enter a couple times. Yeah, there you go. And paste that bad boy in there. And then same thing, pull all the rest of them up so that they're all in one export. Perfect. And the one thing to add, like around line 10, is I want you to build one that will do an ID. But why don't get an individual? But why don't we look up the syntax for passing in an ID? Okay.
Okay.
I'm going to stop sharing. I'm going to start sharing, and I'll just show you how I would look something like that up. So let's pull in a browser tab. So I know that the part of my computer program that's handling HTTP requests is this framework called Express. So I would just type Express and I say pass in parameter to route. Look at that. It's the very first one. Pass parameter to route. Okay, good. How do I pass a parameter to express.js router? So Express.js has a routing guide. And this prints about birds when they do. So this is still a text pattern, but we want the ability to pass in a variable, a text that will be different each time. It might be ID 1, it might be ID 1 million, right? So if we go down here, this is still not it. I don't like this example at all. Let's go back. I don't see any. I might even do an ID parameter, even though it's any parameter, but ID is so common. Passing a get parameter to express route. I'm wondering how I can get a parameter from the get request and pass it into the route handler. That might be it. I'm new to Node Express, trying to build a simple functionality. I'm wondering how I can get a parameter from the get request, pass it in the route handler. Yeah, okay, that's close. Now, there's a couple different ways to do this. I want to look at what he's trying to do and just explain a bit about it. Okay, this URL that he has right here has about 4 or 5 pieces of information in it. And they all relate to this specification called the Hypertext Transfer Protocol, right? Which is what we've been learning a lot about. We discussed almost all of this over the last couple of sessions. This first part, this is just what protocol is my communication going to use. There's lots of protocols out on the internet. There's Hypertext Transfer Protocol, like we're looking at. There's File Transfer Protocol. There's Mail to, like email protocols. There's lots of protocols. This is the protocol. This is the domain, this part right here, localhost 5000, that's the domain, right? Including this port. And then everything after the slash is the path until you get to this question mark. Now, we haven't discussed these question marks that might be in the URL. Have either of you encountered these yet in your own studies? Everything after a question mark in your request, your HTTP request, is what's called a query string. And a query string is a string that's formatted in a special way. We do this all the time in computer programming. We take strings and we format them in a specific way that if they arrive at a computer program that knows what the format is, they can read through the string and pull it apart to indicate some intelligence, some concept. Here, the structure of this string, ID equals 1, 2, 3, is just a key value pair, which we also encounter about a bajillion times in programming. On the left of the equal sign is the key, ID. To the right of it is the value of that key, 1, 2, 3. So you might actually have multiple of these query strings, ID equals 1, 2, 3, and then you do, I think, an ampersand or something like that. And then you'd have like username equals Eric Gross. And you can have multiples of these things. And when they arrive at whatever program this HTTP request is sent to, it's the responsibility of the programmers who made that program to be able to read through here and pull these things out. They pull out this query string I'm talking about of ID equals 1, 2, 3, and they'd find the key part ID because it's before the equal sign. And then they find the value part 1, 2, 3 because it's after the equal sign, and then they can use it in the program. So this is one method we could use. Any questions about that concept? Okay. There's another way to do it that I'll show you as well, but just to explain like what he's asking for. He's like, hey, listen, I want to send the request in, and in this query string, you know, everything after the question mark, I want to pass in a parameter. I'd like that to be used by my computer program. How do I do this? And let's see if there's an answer here that I like. They say, don't even use that route of query strings. They say, do what we're trying to do. Have, instead of using this question mark, and then after that be a key value pair for ID, instead, just do a slash and then send them some text. And again, it's our responsibility as the programmer who receives that to know what it indicates. It indicates an ID. We know that. Why? Because we're the ones that told the consumers of our API, hey, if you want a request with ID of 123, just send us /request/ and then the ID number. If you do it in that format, we'll handle it from there. We'll pull those two things apart, the requests part and then the 1, 2, 3 part, and we'll use them for separate things. The request part is part of the routing. 1, 2, 3 helps us find the individual exact request you're looking for. That's our job as programmers to make it work that way. And we just need to tell the consumers of our service, please format it this way, and we'll take it from there. Any questions about that? Well, look at how they do that. Here's a perfect example. Here's the app.get, and the pattern is /whatever, and then /, and then the name of the parameter. And notice the line immediately below it. And this is all some magic that Express lets us do. It says, if you grab the request object, remember the request object is created by the Express framework, right? We get to access it. The request object has other things inside it, including a collection of parameters. So the Express framework itself has already read through this text that arrives. It knows the format, and it pulled it apart. It said, oh, it's got a colon right in front of it. That means it's a parameter. Everything after that is the name of the parameter. I will add on to this request object inside a collection called params, a key called ID with a certain value. And all that magic, which might be, I don't know, dozens or hundreds of lines of code, all of that happens for free for us. The Express framework programmers made it. That's the pattern I use a lot. And it's very common when you're making APIs to use this pattern of just tell them to put the number there and that it has to be a valid ID, and we'll take it from there. That's the pattern I want to use. We could build it the other way, where they put it in as a query with a key value pair. Any questions about this example right here? That's what we're going to build, okay? So I'm going to start by building out the get an individual product, and we're going to do it this way. So let's go back to my code, and I'll put down here route to get an individual, or to get a product, and you guys should follow along by ID. So I know I can use my router object and I can use the get method. And here is where I'm looking for that exact syntax. Let me look it up. It's slash whatever, and then slash colon my parameters. So I already have the slash whatever. It's down here on line 13. If they do that and then they have a number, I'll call that the ID. And then I'm going to define the function to be executed if, in fact, they send this pattern. Unless you get caught up. All right, now, what do we want to do right now? Well, eventually, we're going to, of course, use this information to look up a specific product. Right now, we're just going to do the pattern that we set on line 8, and we're just going to send a response back just to prove that we arrived here. Reached the get. I don't know how I moved the cursor. Reached the get product by ID router. And that looks good. I like that. Raise your hand when you're caught up. Perfect. So now let's test whether we can reach this in much the same way as we did. Let's start our program, of course. Okay, let's go down here. I want output on terminal. Give me an npm start. Make sure I don't have any errors. All right, so my API is listening. Let's go to our test one. And first, let's test the one we know works, which is top. Let's check top level. I get an OK. Hello from the API. Let's test get all products. I get an OK. I reach that router. Are both of you also getting that? Good. So now let's build one. Get product by ID. Now, did either of you already build this yourself as well? Okay. All right. So Alexander, you just sit tight and look at yours. Dana, I'm going to ask you to help me craft this right now. What should this request look like? And it's okay if you have to ask questions or if you're not certain.
So I think it would look the same as the one above, but it would have also slash colon ID.
Close. You don't put the colon. That's the only difference. You don't put the colon. Express doesn't need it. Express knows that if after the products text, there's a slash and anything, then it'll be the ID. And you don't have to code that out. It's just magic. And if we look at this example, that's how they did it right here. Notice that there's no colon, but it's down in the code that you put the colon. Make sense? Okay. Other than that, yeah, absolutely right. Let's try it. Hey, look at that. I got an OK. And the message reached the get product by ID router. So we've successfully hit that. Did you guys both also get that? Sweet. Okay, good. So now we have a pattern we can use to build out the rest of these. So I'm going to let you guys do that. I'm actually going to stop sharing. And I want you all to build out the rest of these. It's probably a tiny tweak, but I want you to tweak it while I build them out as well. And if you get stuck on something, just let me know. All right. And then we'll show everyone who's watching later on what we came up with. So I have a route to create a product. And make sure you also create a test, an HTTP test for each one. All right. I'm done. You guys done? Okay. So, oh, I'm not done because I didn't build my HTTP methods. I apologize. Well, let's go ahead and build those together. So this is what I have. We had the get all, and we just built the get product by ID. I built create a product with a post, and I built update with a put and passing in an ID, and I built delete with passing in an ID. Is that what you all built as well? Okay, good. So now let's build the tests for this. Update product by ID. Now, we are, of course, going to need more information when we update it. We'll solve that challenge along the way. I just want to make sure we can get the request to the right place for now. So this is a put to do an update. There we are. Got to pass in what ID. And this is see. Back in here is create is what I put in the right order. So that's a post. And you don't have a number when you do a create. And then we have a delete product by ID. Is that what you all built as well? Okay, so let's go ahead and restart.
Sorry.
Did I miss something?
No, I just have a question.
Yeah, go ahead.
Can you explain why we're not adding the number or the colon ID when we're doing create?
Yes. The ID is created by the database at the moment of creation. Also, does that make sense?
Yeah, so it's just assumed that the database just auto creates.
Yeah, but here's another reason why. Let's think about this logically for a moment. It's actually really important. I'm actually really glad you asked the question. Let's say there's like 20 people, 20 customer service reps, or 20 employees, and they're all logged into this API. They can all send requests into the API at any moment. You picture that? And let's say simultaneously, two people want to create a product. There's different products. One's a pencil, one's a tracker. how are those individual human beings going to know what ID to use if they have to come up with it? Let's think about that. Let's solve that. Like, how could they know for sure that the number they're going to choose is valid? What are some ways they could do it? Never mind the exact syntax or language or any of that junk. How could they know that they are about to give it a valid ID that isn't being used somewhere else?
They would just have to communicate that, but that creates a whole nother step.
Yeah, they'd have to like call down into the database and find out what's the next available number, right? And so let's say the next available number is 1,000. But two people on opposite sides of the building both go to create a product at the same time, and they both choose 1,000. One of them is going to get there first and use up that 1,000 as an ID. Even if the other one comes in a few milliseconds later, that ID of 1,000 is already taken. Does it make sense? Okay. The reason this is actually a really great question to ask, Dana, is that what you're bumping up against is the problem of state, the condition of a thing. At the moment of creation in the database of your new product record, at the moment they entered a new row in the product table, the state or condition of the database table changed. Suddenly there's a new row. How is anyone else going to know that? Any consumers of our API, they're not going to know. And this is just a technical problem, or I won't say problem, it's a technical factor you always have to think with when you're creating programs. If you have a persistent storage, a place where you're permanently storing data that's going to be used at a later time by your company, then there's no way any computer program that's external to that database is 100% guaranteed to know the state of the database. There's just no way. You see the problem with it? I'm calling it a problem, but you see that factor, right? Okay. One of the things we haven't really discussed a lot about this way we're building the API is that this is a way of building an API that conforms to a concept called REST. REST stands for Representational State Transfer. There's a real problem with the web related to what we just talked about. The web has all these external clients, people using browsers. They will send requests in to a web server, and that web server will connect to our permanent storage in the database. It's that diagram that I think I can actually, I can't pull it up on my iPad, but it's the diagram we used last week, right? We have the client on the left. In the middle is our API program that we're building right now, all of us together. And on the right is the database. That's the way the internet works right there, or the web. That's the way the web works. Almost every website's like that, right? So this issue of not being able to be certain about the state of what's down in the database has produced a lot of problems over the decades. And one attempt to deal with that is this thing called representational state transfer. And what it says is, if the people building a computer program down on a server and the people building clients like databases, building clients like browser programs, right? If those two people can coordinate and obey a certain set of restrictions, then useful programs can be created, even though you can't be 100% certain of the state of the database. And that's another reason why this particular way we're building API is done this way. If you think about this, one, if you look at the create, let's look at line 11. This is a great question you asked. Well, why don't we have to specify the ID? Because we don't know the state of the database when we send this request in. It's up to the database to create the product and then inform us of the state How does it inform us? By sending back the ID of the newly created product. Make sense? Okay. There's a lot more to study about that representational state transfer stuff, but your question brought that up. It's an excellent question. I keep looking this way because I moved your pictures over there. So, hi, even though you're not there. Anyway, that's why you don't have the number. Make sense? Perfect. Okay, good. All right, so let's go ahead and start our programs up. Make sure I didn't make no errors. Okay. And you should all test yours and see if they work. The top level works. Does it work here? Yep. Get all products should work. Yep. Reach the router for get all products. Get product ID. Reach get product by ID router. Create. Reach create product router. Update. Reach update product router, and then delete. Reach delete product router. All of yours is working as well? Okay, good. All right, now I want to actually connect the database now, because that middle piece that's missing is the controller. But the controller is going to need that whole object relational mapper SQLized thing working. So let's look at the structure we have on the left here. So far, we have the top level of our application in the app.js file. Then we have a router one level below that, one step into our computer, into our application. We have our routers. And now we want to make a new folder called controller. So a new folder at the top level called controller. Or did I say file? I meant folder, new folder. Oh, did I already make one? I already made one. I'm being an idiot. So we have controller. There's nothing in there right now, and that's fine. We need one for the database. The typical name of the folder where you put all this database information is called model. M-O-D-E-L. Now, right in here is where all of our object relational mapper information is. Right in this folder is going to be everything that's needed to move between rows in our table down the database and objects, product objects in our computer program. We've discussed that several times. Now, the SQLized object relational mapper that we're using makes the process of setting this up relatively easy. Because what we want to end up with is our computer program being synced up with the structure of our database. We can do a lot of this almost automatically. And I want to go to the documentation for SQLized to show you what we're talking about. SQLized, connect MySQL example. That was from before. So let's go to I want to see if I can find the actual SQLized website. I'll just go SQLized documentation. Yeah, SQLized.org. Okay, so let's go to the source here. Getting started. We looked at a lot of this. All right. We installed SQLized. We know how to connect to the database. We even did this thing where we were able to send a query into the database. Okay. We know how to do all this catching thing. We did all this stuff. Okay. What we care about now is how to set up models. So let's go here on the left where it says model basics. You'll learn what models are and how to use them. The model is the essence of SQLized. It's an abstraction. Anybody take a crack at defining what an abstraction is? Let's see if we just define it and see if we find a decent definition. Abstraction in computer science will be much better. We'll try Wikipedia. I don't like Wikipedia very much. Extraction of relevant information from a larger data set. Simplification, separating the signal from the noise. See if that. No, I still don't like it. Finding definitions for technology terms is really tough. Ah, I like this. Creation of interfaces to hide the inner workings of computer programs. The interface is a point where two things meet. We know that from discussion of the term API. An application program interface is the point where two programs meet. Because an interface is the surface of something that can be communicated to. So, in general terms, what an interface is inside programs is the externally available surface of an object that you can interact with. You can send communication to it. It can send you communication, but you don't know what's underneath it and how it works. Does that make sense? Okay. So now if we look at this, it's an outer surface. It's an object with an outer surface. And you don't know how it works underneath the hood, but this object represents a table in your database. Now, we can be a little more precise because we're dealing with JavaScript right now. When we say it's an object with an outer surface that you can interact with, it's a JavaScript object. Specifically, it's a JavaScript object called a class, which we have discussed a little bit. So a model is actually just a class. And that class is a wrapper around a bunch of code that can connect to your database tables. You just have to deal with that outer layer, and it's a JavaScript class. We're going to revisit this definition once we've built our model, because you'll see it in real terms when we have a product model. All right. And again, it's a class that extends model. This model tells Sequelize, the library, several things about the entity it represents. When we say entity, an entity is something down in the database. What's the name of the table? What are the columns it has? So we're going to have a JavaScript class representing a table in a database. These models have names. The name doesn't have to be the same name of the table it represents, but it almost always is. Usually, the model, in other words, the JavaScript class, will have a singular name, like product. The table in the database might have a pluralized name, products. What did we do in ours? I forgot. Let's look at our database. I'm starting up MySQL Workbench. Very slowly, apparently. So we had, what do we call ours? Sample DB? Oh, we call it, yeah, complex DB. All right. Yeah, we call it product, so it's plural. So that means a model in Sequelize has a name. Our name is going to be product, just because that's what's common. The model will have a singular name. Table has a pluralized name. This shows you how to define a model. Now, I want to point out something really interesting about this first bullet point. Sequelize is the library that we use. Built into it is a function called define. We can pass in what name we want for the model. What are its attributes? That's like its columns. And some other options that we'll get into later. So in our code, this is all JavaScript code. We can say, hey, create a model called product with the attributes ID, price, SKU, name, quantity, description, right? And it would make a JavaScript class for us to use. So let's look at the example they have. To learn with an example, let's consider we want to create a model to represent users. They have a first name and a last name. The model is a user. The table it represents is called users in the database. It's a nice JavaScript. From the Sequelize library, we're going to pull in two different useful objects. The Sequelize object itself and an object called data types. We've seen this syntax before. This creates a new running instance of the Sequelize class. Using this, we can connect to the database. Now, they're not using MySQL. They're using this really lightweight relational database called SQLite. But this line creates a live object that can connect to the database. Any questions so far? Okay. So every time you see this lowercase Sequelize, it means we're using an object that can connect to the database, as in this next line. Here's where we make the model. Remember, the model is singular. We use the connection to the database and run the define function. We say we want our model to be called user. And remember, I told you that attributes are like the columns. The attributes are first name, it's a string. It can't be null. The second attribute, which corresponds to a column, is last name, it's a string, and apparently it can allow nulls. You don't have to have a last name. And this is just, hey, it'll show that that actually occurred. But this is the simplicity of it right here. This makes a model because we can connect to the database with it. Questions so far? Okay, now, here's a weirdness on this already, though, or weirdness on this. We already have a table in the database. And we know what the columns are. Sequelize has the ability to connect to the database. Now follow this. It's magical and it's beautiful. We can use Sequelize to connect to our database that we made called ComplexDB and to read through all of its tables. There's only one of them. And to read through the columns on that table. There's 6 of them. And Sequelize will then make a model class for us. We don't even have to write the code. It's beautiful. And that's what we're going to make it do. So that comes from, let's see, we'll do Sequelize database first. How to import definitions from an existing database. How do you Sequelize on an existing database? All right. There's an existing database with different naming conventions, blah, blah, blah. Take a different approach where you want to create models that adapt to the existing schema. Remember, a schema is just the structure and relationships of a database. What's our structure? Oh, it's super complex. It's one table that's not related to anything else because there's only one table. Our schema is really simple. Short article explains the steps you need to take in order to work with Sequelize in an existing database. All right, so install dependencies. We've already installed this. We've installed Sequelize, and then these ones, these have to do with a different relational database management system from MySQL. It's called Postgres. We installed Sequelize and the Sequelize library, MySQL 3 or MySQL 2, we called it. What do we call it? Well, it's here under node modules. I think it's called MySQL 2. I think it's, yeah, it must be inside Sequelize. Huh, we might need one. I want to see if there's an example with MySQL and make it easier. Let's do Sequelize database first MySQL. Let's do it. Let's find an example that uses exactly what we have. How do you Sequelize with Node MySQL? Getting started Sequelize. Let's try that one. How to use Sequelize on an existing database. MySQL connection. All right, let's look at these examples. Getting started. We've already seen this. How do you Sequelize with Node and MySQL? Hey, we're using Node and MySQL. Okay. This says creating a database table using Sequelize. We don't need to make the table. We already have one. So that's not what we want. How do you Sequelize on an existing database? Yeah, that's what we already saw. How to create MySQL connection with Node using Sequelize and Express. Yeah, let's see. I want database first. Might take a little bit to find it. Connect existing database with Sequelize with code examples. Connecting existing database, guys. How to solve connecting existing database. That's really not helpful, thanks. Automatically generate models from your database. Oh, this is some program somebody made to do it. Nope. Sequelize, create models from existing database. That's what I want. But I want MySQL. How to import definitions. Create the model classes. We need to, that might be it. How do I make a model Sequelize for existing database? Nope, that uses a different, that uses that Postgres thing. There it is. Okay, so this says to use this library called Sequelize Auto. All right. Create database models for existing database tables. That's Python, shut up. If you have existing tables in the database, you want to convert into Sequelize models and use this library called Sequelize auto. Okay, this might work. So we install a separate library. We already have actually, we might not have installed MySQL. Oh, look at this. Use a below command for converting to models. This is atrocious. You know what? I think we'll actually type them out ourselves. Let's make them ourselves. We know what our columns are, and we call them attributes here. So let's try to build this, all right? All right, so I want you all to follow along with me. I'm actually going to put these side by side, and we're just going to try to build this. Let's see. Here we go. And we want to do this. Let's see, we have a model in here. Let's make a file in the model folder. And it's going to be called model.product.js. And let's close this. I've got some more room. And let's start building this. So all right, so I'm bringing in those two objects from the Sequelize library. Now I want a live connection to my database. Now, we solved this in a different project a few classes ago. I think it was the complex JS. So let's find that code instead of trying to work through this, because I remember it being a giant pain in the butt. Let's go to File, open Recent, Complex JS. And I think it was db.config. Is that right? Yeah, look how we did it here. Remember this? We have a separate config file. I'm going to copy this. You guys can want to do that if you yourself. You all have complex JS on your computer. Copy that. And let's go to the other project. Our API. And here inside the model, let's have a config file. So new file and be config.js. And let's paste that stuff in there. All right, raise your hand when you're caught up. If you need any help, Dana, let me know.
I'm good.
Awesome. Okay. Now, I don't want to switch back and forth. Let me right click on this and open up Complex JS in another window. So where do we use this? Here's our config. I think in import DB we used it. Or maybe update. Nope. We might have just done it in app. Where do we build this? Here it is. We pulled in Sequelize. Import dbconfig. And then here's our const Sequelize. I'm going to copy all that code. You guys should be able to find this as well. If you look in your complex.js, in your read.js, we built all this a few weeks ago. If not, we can type it out. We'll get it working. So let's go back. Let's go to our model.product. So let's see. There we go. Okay. So that should work. Let's think about this. We're pulling in our config data. Now, that path is wrong though. So delete that, do a ./config.js. There, okay, there it is. So we're reading in the config data. We're using that config data right here to establish a connection. So now we should have a live connection to our database. Raise your hand when you're caught up. Got it, Alexandra? Let me know when you're done, Dana. Awesome, I see it. Okay. So let's go back to our example here. There it is. So we've done this first line. That is on our line 1. This line right here required pulling in the config data, but we did it right here on line 7. And that should work because we pulled that over from our complex.js project, and we each were able to connect to that database using that. So that should work. So now we need to make a model. So let's even do a little comment here. And this is product model. It's a product model class. So let's do a const and we'll call it product. And we're going to use that Sequelize object we just created on line 7. It's got a function in it called define. The first thing it takes is the name of the model. So in single quotes, we'll do product. Second thing it takes is a collection. So because it's a collection, we do curly brackets and hit enter. And these, again, they're called model attributes, but they have to correspond to columns. So let's look at our columns. We have ID, price, SKU. So ID colon, and in here are some properties of that attribute. What type is it? Well, let's look at this data types thing. It'll probably help us. Now something's wrong. Look at line 1. Line 1 is where we're supposed to be importing this thing called data types from the Sequelize library. Line 15 should be able to give us some IntelliSense insight into that. I think it's an integer. We'll have to look this up. Let's type out what we think it is, and then we'll have to see what kind of errors we have and look at the documentation. Allow null. We're definitely not going to allow null on the ID. And then we go down here after that curly bracket for ID, hit a comma, and we can do another attribute. What's the next one in the table? The next column in the table?
Price.
Say it again. Price, right? All right, some curly brackets. And I believe an integer should work. Again, we'll look that up. We are absolutely going to require, well, let's look. Or do we allow null on the table? Let's look at the table. How can we find out whether or not we allow null on any of these things? Any ideas? If you right click on the table name and say send to SQL editor, if you send the create statement, it'll show you the SQL that would result in creating this table, including everything about the columns. So here we are, create table products, ID, it's an integer, price, it's a decimal, and it says not null. We're gonna have to look up these data types, aren't we, for Sequelize? Decimal is different. Well, let's do the allow null of false. But we need to look up data types. It's really weird. I'm going to enlarge this. I don't know why it's not looking this up for us. It should pull that in right here. Did we spell it wrong? Data types, there it is. Data types dot string. All right, so let's look up Sequelize data types. Sequelize data types, practical guide. Data types are core to the Sequelize library. Text types, string and char. Number. Integers, float, real, decimal. Look at that. So integer and decimal, that'll work. And decimal accepts 1 or 2 arguments for precision. So let's see how we pass those in. The arguments. We know our precision in the database. 10 and 0. All right, let's look at decimal number accepts 1 or 2 arguments. Let's see if this cheat sheet shows us the syntax for decimals. Oh, this is something you pay for. How about if we go let's look up syntax. Sequelize data types, decimal syntax. Sequelize.org. That's what I want. Okay. Data types, built-in data types. You must import data types, which we did. Import data types. MySQL. So the SQLized data type corresponds to a varchar in MySQL. Boolean integers, there we go. And we want decimal, right? Where's my decimal? Interesting. No decimals? Inexact decimal type. Exact decimal numbers. Okay. So decimal. There's no syntax. Just says make it a decimal. That's really weird, huh? Oh, okay. Here's an example. Okay, good. So we can do decimal and then it'll match the way it's defined in our MySQL. Put the comma, the precision data. So our precision data is 10 and 0. So we should be able to say decimal 10 and 0. All right. So this should be able to be decimal. And then 10 comma 0. And that should correspond to what we have down in the database. All right. What's the next column that we need to create an attribute for?
It's going to be skew.
Awesome. And what is that? Skew is a varchar. Let's see how we specify that it's a size of 10. So if we go back to that documentation and go to strings at the top, said string, booty string, and then in parentheses, we put the size. That's the same as the varchar with the size. Okay, good. So we need to do type, string, and then we do, don't you lowercase that. And then we do 10. Oh, I didn't do data types. That's why it was mad. Like that. That looks good. All right, now do we allow nulls? Yes, we allow nulls. All right, so we can erase that comma and we're done. All right. What's the next one?
Name.
Excellent, thank you. All right, and type. And this is a string, right? But what size is it here? 255. And I don't think we need to specify it, but let's try it. But we know it's 255 because it's right here. It says name varchar 255. Okay, good. And it allows nulls. Okay, good. All right. So that's name. What's the next one? Quantity. It's an integer and it allows nulls. So data types. Dot integer. And what do we say for size here? Just integer, doesn't matter. Okay, good. Awesome. Does it allow nulls? Yes. All right, so we're done with that. I think so. Last one is description, varchar 255 and allow nulls. So string is for varchar. And we need 255. Now let's see how we're doing here. If we pull this over and do 50-50 with the documentation example. I think the example was right here. There it is. Okay. All right. So curly brackets. Right after the word of the product, this is the name of the model. There's a curly bracket. It goes down to here. And then there's other model options, but we don't have any. So that should define our class. Okay. All right, let's see where we're at. So we have a class. You guys all cut up to where I am? Okay. So how the heck do we use it now? We have a model, okay. And it says model instances. Remember that this is a class. A class is a description of the appearance and behavior of a thing should one exist. You need to make an instance of a class for there to be one of them in your program that you can use. So we want an instance of a product class. So let's go to model instances. As you already know, a model is, anybody remember what ES6 is? It's from way back when we first started studying JavaScript. It stands for ECMAScript version 6. In 2015, a bunch of upgrades to ECMAScript, which is the specification for JavaScript, a bunch of upgrades to JavaScript basically came out. And one of them was that JavaScript finally allows classes. So when it says it's an ES6 class, that means it's a feature of JavaScript that came out in 2015 that allows you to have classes. An instance of a class represents one object from that model. That object, this is super important, maps to a single row of the table in the database. So for this guide, the following setup will be assumed. We've done this. We've set up model data type, data user. All right. Oh, interesting. The sync. This is what we're missing. This makes our model sync with the database. Let's look up how to use this sync thing. What we wanted to do is make it so that these attributes, name, favorite color, age, whatever, our examples, of course, of attributes are ID, price, SKU, name, quantity, description. We want to make sure that those get synchronized with the columns down the database. So I think we can use this. Let's see how to do this. I've never done it this way, so this is new for me as well. I don't do it this way because it's chunky and clunky and a real pain, but I want us to go through it rather than showing you fancy tools later. Oh, interesting. A model is a class. Let's look up this sync thing here. I think we can close a bunch of this stuff. How to use sync in Sequelize. How do you Sequelize sync? So we have a Sequelize instance. If we look at our code, on line 7, we've created a Sequelize instance. The Sequelize instance has a method called sync. It synchronizes your Sequelize model with your database tables. The synchronization happens at the table level. If a table doesn't exist, when you call sync, it'll actually create a table for you. Let's see an example of the sync method in action. Suppose you create a SQL model instance named invoice. So this is Sequelize.define. We've used this. We have an example of this right here, Sequelize.define. Here's the name of the model. And it only has one attribute, which corresponds to a column. So on the invoice class, you call the sync function. It'll say create table if not exists. We already have one. Okay. You know what I think we're going to do? I'm rethinking our approach to this. I think I want to make the class like we have and have it actually just generate the table for us. Yeah, I want to generate the table for us. Okay. All right. So here's what's going to happen. We make a model class. We've already done that. We can call sync on it and it'll make the table for us. We just have to delete our table and it'll make one for us. Notice what's interesting. We only specified an attribute of amount. Sync makes an ID column for us. Look at that. And sets it as the primary key. All of that is part of the Sequelize function. I like that. Let's test this out. I think we'll do that and then we'll pick up on Wednesday. Let's go here. Let's take out this first attribute, ID, because it'll get auto-generated for us. Okay. And we want to do the sync. Now, where do we call sync from? I think we can call sync when we start up the application. Let's look at this for a minute and think this through. Here's our app.js. We want, when we fire up the computer program, to connect to the database and run this sync, which will create the table if it doesn't already exist. You guys agree with that approach? Okay, so let's make some space here after our API test. And let's just say connect to DB and use Sequelize sync to create table if not exists. All right. Now, in order to do this, the code we're looking at right now is actually going to have to create a live connection to the database. We know how to create a live connection to the database. We can see that right here. So why don't we, just to see if we can make this work, let's try to do everything we're doing right now, right in the top level in app.js. It's not going to stay there, but I just want to see if we can make this work for now. Okay. So what I want to do is reproduce what we have here. Watch this. If I go right click here and split to the right, I have a second copy of it. I can go to app.js and I can start copying this. All right. So we want to bring the Sequelize library right here into the app.js. We're not going to leave it this way. We'll refactor this on Wednesday. So let's do the const. Okay. Now we want to import our DB config. Ooh, look at it, auto-completed that. It went down into the model folder and found the config. Thank you, Visual Studio Code. I'm just going to copy this bad boy. This establishes my connection to the database. Raise your hand when you're caught up. Okay, good. All right. So now I want to try, I want to create a product model class. I'm going to put all this in here, copy all that. Again, it's not going to stay here. And finally, I want to do the sync. I have a live connection to the database right here. Now I'm going to call my sync. Let's see how we do it. It said you call product.sync. If it succeeds, then we'll log. I'm going to copy that whole thing right there. You got, and you guys will have to type it out. So it'll be product.sync. All right. All right, now it might throw an error. Let's just see what happens. Let's do an npm start. Yep, threw an error. Totally fine. I absolutely suspected it would. Oh, interesting. App.js line 5 There's, oh, that's right. This import thing, we had to do it a really wonky way in that other program. Because it wasn't, it was a janky command line program. So we don't want to import. Let's see how to do this the correct way. Can I use import? All right. Let's look up the right way to do this. I think I'll find it here. So here's config data. Let's see where we use that. I think we use it right here in models. There it is. Look at that. Const equals require. That's how we do it. So change line 5 to const dbconfig equals require. Parentheses. Okay. That should pull in the export from our config.js file. Raise your hand when you're caught up. Awesome. Now let's try an npm start, see what other errors we throw. Cannot find module sequelize. Did we not install sequelize yet? Node modules. Okay, npm install -- save sequelize. Oh, we did it on the other project. Do that to install the sequelize library. That's why the data types wasn't prefetching for IntelliSense. Raise your hand when you're done installing. Okay, yeah, you guys are faster than me because you're not streaming. Okay, now npm start. Let's see what else we run into. All right. Unexpected token export. Line 5. What? Unexpected token export. App.js line 5. Is there something wrong with my config file? Let's look at our config file. Config.js. Let's put it over here. Export const dbconfig equals. Maybe that isn't how to do it. Let's look here under. So what does it look like here? Config.js. Oh, module.exports equals. Okay, good. So change this to module.export equals. There we go. You guys make that change? All right, now let's try it. Oh, we don't have MySQL 2. So npm install -- save. MySQL 2. We're getting closer. That means that it read through here and found out that the dialect is MySQL. So that's good. All right, let's try that. Hey. Yeah. Okay. All right. So the cool thing about this is we've established we know how to connect to the database. Okay. All our configuration is set for that. When we come in on Wednesday, what we're going to do is wipe the table in the database. And then we're going to experiment with making it so this product model that we're making creates a table for us that looks the way we want it to, that has a primary key called ID, that has those other properties or other columns. We'll do all that on Wednesday. Cool? Okay. All right. So this is hard, this part. Okay. You've seen that. We have to look up a bunch of stuff. We have to get it all wired up. And when you're building a project, this part is hard. Making it so that your computer program that sits on the server, in this case, our API, can interact properly with the database. It's just challenging in almost every scenario. And I want us to work through this and feel the pain for it, and then get it up and running and see how it is. So that when you encounter that in the real world, you'll know it isn't the smoothest, easiest thing sometimes. I could have used a pre-made framework that has all that just all glued together real nice, but that's not nice. I don't want you guys to think that that's the way it goes all the time. All right, thanks so much. Great night. Any questions before we end off? Okay, cool. Dana, if possible, 1 week from today on Tuesday, I think I'll be free. I'd like to do the re-record, okay? Of that.
Yeah, that's fine with me.
Okay, cool. Awesome. Okay, excellent. Thanks. Have a great night, folks.
Have a good night.
Bye.